Right. Hi, everyone. So as George said, my name is Ahmed Tikiwa. I'm an Android engineer at Luno. If you want to get a hold of me on Twitter, my handle is at Ahmed_Tikiwa. I am a software engineer, full stack web developer, as well as a mobile developer as well. But my primary passion is actually mobile development. And for this talk, I'll be talking on from the trenches, zero to prototype, how Android Jetpack helped me build an app for a hackathon. So a bit of background. So 2020 started off well, and then things just started going wrong with regards to COVID-19, which basically just turned the world upside down. Now, COVID-19 reshaped what we know as normalcy. Everything about how things we went about doing just changed dramatically, and so termed the new normal. So one of the things that happened during this time was there were global lockdowns, different countries around the world instituting lockdowns. Institutions were closed, schools, businesses, they had to shut down in order to prevent the spread of COVID-19. People were then forced to work from home remotely. However, there were some who were not as fortunate to be able to work from home remotely, so there were job losses. And it is actually because of all these factors that led me to want to find a way in which I could help through technology and help tackle these challenges and issues that the world is experiencing to be able to help communities around the world. And in my search, I actually came across what was termed the Build for COVID-19 hackathon, which was basically a hackathon inviting developers around the world to build solutions, software solutions that will help drive social impact as well as tackle the challenges associated with COVID-19. Now, this particular build for COVID-19 hackathon was actually backed by top technology companies such as AWS, Amazon Web Services, Facebook, Giphy, Microsoft, Slack, Pinterest, Twitter, and to mention but a few. So within this hackathon, I basically was tasked to build an app, an Android app, and this is what the demo app needed to do. So we called this project Liam, which is actually named after my son. Fun fact. And so our project was aimed at being a learning platform for kids, and these kids could earn liams. So this is the digital currency that we coined. So you earn liams for completing courses. You earn liams for selling your digital assets. So these kids could sell their digital assets on this platform, and then they'll be able to use liams to actually buy digital assets. And we basically constituted of a global team. Like I said, this hackathon was a call to everyone around the world. And so the different countries represented within the team, Liam, were from South Africa, myself, from Uganda, Canada, India, and Ghana. So this Android prototype was supposed to constitute of the following: a sign-up screen, a login screen, a marketplace screen, a course catalog screen, and a profile screen. I only had 3 days to actually develop this app. So yes, it was a mammoth task to be able to do this. And unfortunately, the API was not quite ready for the Android side to be able to use it. So the data needed to be mock data that will then be used within this app. However, with the intention that when we do actually plug in the API, this app will just be able to just connect to the API easily. So this is what the app constituted. This is what I ended up building. So as you can see there, these are the different screens that I had to build, and these are the screens I built within 3 days of the hackathon. So there's a login screen, the sign up screen, that's the dashboard, the course catalog screen, as well as the marketplace screen. So we basically had an approach, and this approach was basically adhering to the hackathon rules. So the hackathon rules required that you could have one of two, either a prototype or a production ready app. So production ready or proof of concept applications. And our goal as Liam, or the project Liam, was that we wanted our project to be production ready. So we weren't really looking at just a mock. So our goal was, even if we do not make it, this is what we aim to do by the end of the hackathon, to have a production ready app that even beyond the hackathon, maybe we could even develop this into a proper project, something that could actually help shape the world. So this particular app that I needed to build needed to be performant. It needed to be clean. In other words, the code needed to be clean and also have a well-structured architecture within the code itself. So this basically led me, it was a no-brainer on my side because I've worked with Jetpack professionally at work. And it was a no-brainer because I know that everything about Jetpack enables me to be able to build this type of project that I needed to do for Liam. So under Jetpack, so what is it? So it is a collection of components, tools, and architecture guidance for development acceleration. The whole point of it is for each and every developer to be able to develop their apps faster without having to spend tedious time writing boilerplate code. So that's the whole intention. That's why it was actually introduced. It's also been considered a template for production-ready code. Because of what they've brought in as part of Jetpack, you can actually say that every particular component can actually constitute components that you can use in a production-ready app. So it becomes a template. And the one thing that they wanted to be able to address was that developers actually said, you know what, data is always changing, things are always changing, and it's always difficult to actually keep up with all these changes, so we need help here. So they actually heard that call and said, no, we're going to build this thing to help you manage these data changes as they go by. So Android Jetpack consists of 4 categories. The first one being foundation, UI, architecture, behavior. And then each of these categories contain components that are backward compatible, that all work together, and that are adaptable, easily adaptable. That's the whole point of it. And this is the structure of basically the architecture, the UI, the foundation, and the behavior. So you've got different components there that are part of each and every category. So on the left there, which is what I'll be focusing mostly within this presentation, is the architecture stuff. So you've got data binding, which is basically allowing to bind UI components in layouts to data sources. I will explain that much later. Then you've got life cycles, which are basically aware of the current activity or fragment lifecycle state. Is it on resume? Is it on create? All of that information. Live data, being able to observe data. So in this case, it's an observable data holder class, and it's also lifecycle aware. Then I'll be touching on navigation around the app. And basically this navigation also has the ability to be able to handle deep links. That's the power of the navigation component within Jetpack. Then view model, to be able to store and manage UI-related data while also being lifecycle aware, just like live data. Then Android KTX, which is a library that I have included in this prototype, is basically Kotlin extensions included in Jetpack, which provide concise idiomatic Kotlin to your app. Okay, so here we also have Fragment, which is basically multiple independent screens hosted by an activity. And as you will see, this particular prototype that I built constitutes a lot of fragments and basically managed by one single activity. So structuring the code. Okay. So basically, the recommendation by Google is when you're using Jetpack, it's actually to use the Mvvm architecture, which is basically the model view model architecture. You're free to use your own architectural pattern, but this is actually the recommended way. So at the top there, you will have an activity. In my case, in the prototype, it's one single activity that basically manages a whole range of fragments. Okay, and then these fragments speak to the view model. So each fragment has got its own view model. And then the view model also has live data, which I will touch on later. And then this view model speaks to the repository, and this repository is responsible for the data. It is the source of the data. And then here you can basically have it in two ways. You can have a repository that either fetches data from an SQLite database, which is basically Room. So Room is also another part of Jetpack. And then you can also have your repository speak to a remote data source, or you can actually have your repository speak to both. So you can have your repository fetching data remotely and then updating your local database for persistence, for data persistence, basically having some sort of cache on your app. So this is this is the architecture that I followed with the prototype that I had to build. Okay, so structuring the code. And then part of this prototype that I'm going to show you, it's going to basically constitute a whole bunch of these components that are part of Jetpack. But before I delve into the code, I'm just going to explain the different components that I actually made use of, the key ones, the notable ones. So the first one is data binding. So data binding, which was introduced in 2015, is now also part of Android Jetpack. It basically means you're binding UI components in layouts to data sources. And it's simple to set up. Okay, all you have to do in your build.gradle file is add this, build features, and then within there, data binding, and then set it to true. That's all you need to do to be able to enable data binding to be part of your app. And then within your layout, all you need to do is just wrap every view within your layout within the layout tag, and then it'll automatically pick it up. And then the benefit of data binding is that you no longer need to do find view by ID, which is obviously something that you have to constantly do when you need to find your views. This basically eliminates that because it helps connect the view to the source. So another thing, if you want to basically convert your layout, Android Studio also has this ability to be able to convert your layout. So in this case, I have a simple layout that is a constraint layout, and then I'd like to be able to convert this to be able to have data binding. All I have to do is click on the light bulb icon, and then click on convert to data binding layout. Click one click, and then suddenly it's actually a data binding layout. It's that simple. So that's a shortcut way within Android Studio that allows you to actually transform your layout. So data binding expressions, which is also part of data binding. And this basically means that you're making data available to your layout using a section called the data section. So there's a data section that you'll need to add to your layout. So underneath, as part of the layout tags, within those layout tags, you need to add the data section. And this is what it will look like. So you have data with the closing data tag. And then within the data tag, you basically define a whole bunch of variables. In this case, my variable is view model. So I'm passing the view model to the layout. And basically to reference it, you need to give it a name. So the name here, view model, it can be any name you want. And then the type, you need to then define the type. In this case, I'm defining it that it is referencing the object dashboard view model. So that's what the view model represents. This view model variable represents the dashboard view model object. Then within your layout, to be able to use it, all you have to do is, so for example, if it's a text view, and then if you call Android text, and then it's the equal sign, and then within the quotation marks, the expression constitutes an @ symbol, and then curly braces. And then what you have within those curly braces is part of the data binding. So in this case, I'm referencing view model, the title. So I'm now referencing the title within the dashboard view model. So it's that simple. That's how you actually reference it. Or in my case, as you can see there, text view app, image URL. An image URL is actually not part of the framework. It is actually a custom data binding object that I've added on my side. So basically, image URL is something that points to a custom binding adapter that I've created, which I'll show you later. And then within there, I can then reference to say, hey, image URL, you're going to point to viewModel.url. Another way is also if you do the on-click, okay, so there you've got a lambda within there, and then which then points to viewModel.onClick. And what this basically means is that the listener is created, it is automatically set on your view, okay, so by doing that, the listener is already created, and then the lambda is evaluated when this event gets triggered. So when the on-click event gets triggered, everything within that lambda basically gets evaluated. And that's how the data binding expression will work. So in this case here, when you then go to your data source, so your fragment, this is how you basically would define the data binding. So we've got here, so binding there, and this is basically a variable that I've set globally within this fragment. And when you have a layout called fragment underscore login, and you basically make the data binding layout, Android will basically automatically create a data binding object for that layout. And this is the object that I'm referencing. So you can see the fragment login binding is an automatically generated object that I can now reference that represents fragment underscore login.xml. And then within here, all I have to do is to assign it, I basically fragment login binding.inflate, passing it the inflator of an onCreate view. And then I can do extra things now within this with this binding object. I can then assign it properties. So in this case, I can then give it the lifecycle owner. And what this basically means is that I can bind the layout to architecture components. So in this case, if I want to basically have live data within my view, I then have to pass it a lifecycle owner. And this basically gives me access to live data if I want to actually use it. And the view lifecycle owner is basically getting it from the fragment. So in this case, it'll be calling fragment.get view lifecycle owner. And then there at the bottom, I'm passing in the view model. So the view model that I've actually defined, which I'll show you later on how to actually create it. There and then passing view model and then assigning view model, which is the one I showed you in the layout, to say, hey, binding, the view model that I have created in this file, here's the object that you need to reference. Okay, so binding adapters. So what are these exactly? So they basically make a framework call to set a value. And what this basically means is that you're using, for example, Android.text, which is actually using the system binding adapter to be able to set the text on that particular attribute in your view. So when you call Android.text, you're actually calling a system binding adapter. And then within that system binding adapter, it's going to call the set text method to be able to set that text on that attribute. You can also define your own custom binding adapters. So for example, in my case, I had a binding adapter which I created, which contains image URL. So this is how it looks like. So you basically create a file that will contain all your binding adapters. So in my case, you annotate it with @binding adapter. And then within there, you then specify what you want to bind to. So I'm then binding this to image URL. So every time app.image URL is triggered or defined in my layout, this binding adapter will then be triggered. And so what will basically happen is that it will then evaluate to see, does this binding adapter support the arguments that have been passed to it? So it will then, so you basically need to define the arguments that are required for this binding adapter to work. In my case, I've said that the image view is one of the parameters. You can pass in a view, any particular view you want. And then, so in this case, I'm saying image view is the view I want to be passed on here. And then I'm then saying, I want a string to be passed on into it. So in this case, this string will basically be the URL. And then what I'm then going to then do with this string is then I'm going to use glide to then set the image to load the image into the image view. So then I use glide with and then get the context from the past image view and then pass in the load and then get the URL, so the URL that's being passed there. And then in case that also fails, I also have a placeholder. In case that an error occurs, I also have a placeholder. And then I basically pass in the into, which is the image view that has now been passed in. And then this, all you need to do in your view is just basically have app colon image URL, pass in a string, and then this binding adapter will get triggered. It will then automatically load the image into the image view. So this is how you could actually define your own custom binding adapter. So the system, like I said, the system also has its own list of binding adapters. And this is basically just one of the many binding adapters that are there. So you've got card view binding adapter, for example. You've also got progress bar binding adapter. You've also got text view binding adapter, which I mentioned earlier, which has set text size, set input type. So every time you actually call one of these Android call on text, you're actually calling the text view binding adapter, which will then call the set text method. It will do an evaluation. Does set text support the arguments that have been passed? If it's true, then it will automatically pass it on. Otherwise, there'll be a data binding error, which you will need to debug. So, furthermore, structuring the code. So now moving on to view model. So the view model is also part of the Android Jetpack suite, and it is basically responsible for the storage and management of UI-related data in a lifecycle conscious way. What this means is that the view model will always be aware of its owner, in this case, the UI controller, the fragment or the activity. It will always be aware of which state the lifecycle this particular UI controller is in, which is what makes it so powerful. And so because of this, data can actually survive configuration changes. For example, if you do a screen rotation, the data will survive this particular configuration change because the view model is aware of the life cycle. And I'll show you in the next slide how basically it can actually do that. And so you should not hold references to UI controllers, so basically activities or fragments or their context within the view model. You can, however, hold the application context. And so, but what you will need to do, instead of extending, so if your view model extends view model, you basically need to change it to extend Android view model, which is basically one that can accept the application as an argument. And then you can basically have the application context, which is fine to actually hold within your view model, because the application context is different to an activity or fragment lifecycle. And then basically this view model is connected to the UI controller, so the activity or the fragment via the view model provider, which is a utility class that you can then implement. Okay, so the view model lifecycle. And so this is where the beauty of the view model comes in that it's actually very powerful. So on the left there, you'll have the activity lifecycle, and on the right there, you have the view model scope. And so this particular lifecycle here for the activity is also similar to the fragment. So you can also apply this to the fragment to be able to see how the view model also survives. So at the top there, you have the activity being created. Okay, so the activity will go through on create, on start, on resume. Okay, then the activity gets rotated. Okay, so you rotate your device, and then it'll go through on pause, on stop, on destroy, on create, on start, on resume. Then it'll finish, and then on pause, on stop, on destroy, and then finally it's finished. But as you can see, this view model scope transcends all of that. It basically becomes aware of everything. So it's aware of when the activity is on create, on start, on resume, every single state. The view model is aware of it. It actually gets callbacks to that information. It's pretty much aware of all of that. So the only time the view model will actually get destroyed is when it's the activity or the fragment is finished and or destroyed. So in my prototype, these are the view models that I used. So like I said there, I have one single activity. So main activity is the activity that will be managing all the different fragments. Okay, so I've got the login fragment, the sign up fragment, dashboard fragment, video list fragment, store fragment, and then each of these have got their own view models that are mentioned down below there. Login view model, sign up view model, dashboard view model, video list view model, store view model. And as you can see, the naming is actually quite close to each other. This is also helps with regards to organization of code. So keeping your names close to each other. So if you have login fragment, also have login view model. Obviously, this is up to you as far as naming convention is concerned, but this just makes it easier to read and just clean. Okay, so live data. What exactly is it? So it's also something that's part of the Android Jetpack. It's basically an observable data holder class. So you can actually observe changes that happen to this live data. It's actually quite powerful. Also, like view model, it is lifecycle aware. So it also is aware of the data, so where it's coming from or where it needs to be posted to, whether this particular requester is alive or not. And so live data will only update active component observers. And what this actually means by active, send update to observer only when an observer is active. So this means when it's in started or resume state. So that is the definition of active. Okay. However, when it's paused or destroyed, an update will not be sent to the one that's observing the information. So when data changes, live data will post an update. That's the beauty of live data. It's alive and aware of everything that is going on, and it'll post when it needs to post, but only post to an active observer. Okay, so now moving on to the implementation. So the dependencies within the app level build the Gradle file. So as you can see there at the top, I've got Kotlin X coroutines to basically be able to have coroutines being implemented in my app smoothly to get off the UI thread. Then I also use Glide, which is basically an image loading library. And then particularly for view model, to be able to use a view model, this Jetpack component, you basically need to add this as part of your dependencies. So lifecycle view model KTX. And then if you're using Kotlin, that is. And then for live data, lifecycle live data KTX. And then I'm also using Timber for logging. And then particularly for navigation, as you can see there, I'm using Fragment KTX, which is actually optional. But in my case, I had some issues, which I'll delve into later. And so this was an attempt at trying to address those issues during the hackathon. But for navigation in particular, you need the navigation runtime, navigation fragment, and the navigation UI KTX libraries to be included. And then within your project level Gradle file, you just need, in particular, the Google repository to be added to your builder Gradle file. So this is the project level builder Gradle file. Within the all projects, you need to add this. So this is how I've structured my code. Okay, so I have Liam, which is my project name there. And then I've got different directories, which basically, this is all just to do with organization of the code. Obviously, on your side, you can actually organize it in whatever way you want. In my case, this just makes it easy and just cleaner for me to be able to go through each and every directory and know exactly where each and everything is. So in my case, I've got bindings. So within these bindings, so I have my image binding adapter. Okay, so these are the data binding definitions that will be stored within the bindings directory. And an example of my image binding adapter, which I showed you earlier, is this one where I'm setting the image URL. And then in my view, this is how I would call it. So like, for example, in store list item, this is how I reference that image binding adapter. And as you can see, app colon image URL, which then calls store item dot image URL, which is a variable that has been passed within this particular view. So this is how I'd reference my binding adapter within my view. It's that simple. And then domain. So in instances, and this is my own personal preference, but there are instances where your app will connect to a network, so basically connect to an API. And so you basically, this API will have its own data structure. It will have a whole list of ways in which the data classes are organized, right? But it's not necessarily how you want them to be named in your app. So basically, I've created this domain section to be able to have my own definitions of data classes. So these are independent to how the network will be, or if I have the database, it will be independent of how the database data classes will be structured. So this is basically to separate it to say, when in my layouts, I want to display things, I'm going to be using the domain models to be able to display the content that I want to show. Again, this is all personal preference, but this just helps me organize things better. So in this domain, I've got store item, user details, and video item as my data classes. And then as an example of a data class, so I've got store item, okay, and then this has got name, likes, downloads, price, image URL. And then to call this within store list item .xml, which is one of the layouts, this is how I reference it. So I'm passing this as a variable within the data section. I'm passing this that way. So the name is store item. And then the type there, as you can see, it references the domain object, store item. And then to be able to then use it, this is all I need to do. So in store list item, here where I say Android text, I then get the name from store item.name. And as you can see, it's using the binding expression to be able to retrieve this information that I need to be able to display. And so I use these domain models within my layout to separate things. And then network. If, for instance, you've got network requests that you actually make within your app, then this will be where you could actually store all your network classes, your services, any of that information. Again, this is also personal preference, but for me, it just makes things better. But for this case, for this particular prototype, I do not have any network calls because, like I said, it's all mock data. Because unfortunately, the API at the time when we did the hackathon, the API was not quite ready for the app. Okay, so moving on to the repository, and this is actually the source of the data for the app. And then this repository contains only one file, which is what I've called the Liam repository. And this is what it looks like. So Liam repository is basically a class, not extending anything. And this is where the data of the app will come from. And so here I've got store list, which is there you can see it's a private property there. So it uses immutable live data. So the private properties are the ones that I've assigned mutable live data. And mutable live data are the ones that are actually going to change. And I only want the responsibility of changing this to be the Liam repository and not a class that's outside of the Liam repository. And then store list is the one that I'll make public. And as you can see, it's live data. So any class that wants to then access this store list will need to reference store list and not the one underscore store list in order to be able to get the information. So any other class that wants to reference this will not be able to change underscore store list, only Liam repository can. And then I've done that for the other variables, videos list, and user details list. And then I've got a method here called get mock user details, which is a suspend function. Essentially, it's basically forcing this to basically fall into a coroutine. And Now I'm also passing in the context, which is the dispatchers.io, which basically forces this to be able to have the IO dispatcher handle the execution of the coroutine. So in a live scenario, you'd basically then have your API call, and this API call is basically a network call that should not be on the main thread. It should only be on the IO thread. So this is basically to mock that scenario. So this particular scenario obviously doesn't use a network call, but this is just to mimic that. And as you can see, I've added a delay of three seconds there just to make it seem like it's actually a network call, just for the experience. And there I've got user details, which is the data class that gets created, and then at the end there it's post the value. So you need to use .post value in order to post the update of the live data. Because we're not on the main thread anymore, post value is actually the one you need to use. And then here we've got get mock video list, which is a similar one to the previous one. It's got a list here, mutable list of video item, where I'm basically passing in a list of video items. And then at the end, I then post the value of the videos list. I'm posting this list over to whatever observers want this information. Okay, and then I have the UI layer. So basically, these are the screens that will be displayed to the user. Again, this is also personal preference. So this is how I've structured it. Then the UI layer, I've got the different screens. So I've got the dashboard screen, the login screen, the sign-up screen, the store screen, the video detail screen, and the video list screen. And then this is how it looks. So for the login screen, for example, this is how the fragment looks. So as you can see, it's got a binding a reference there, this variable. And there, the reason why I've actually done this underscore version of binding as well as another binding there is just basically to have this variable and be able to clear it in on destroy, which I'll show you later. Just basically clear it out, make sure there are no more references to prevent any memory leaks. This, obviously, you can do your own implementation of doing this. This is, again, another personal preference. And as you can see here, this is how I'll actually reference the view model by using the view model provider. So there I've got view model, which extends login view model, and I'm loading it by lazy. And then I'm using the view model provider. And then this at login fragment is basically the owner, that will be the owner of the view model. So you're passing in the owner. And then I'm using the login view model factory as part of this view model provider. And then that's how I'll get access to the view model. And then in onCreateView, as I showed you earlier, so having the binding there, fragment login binding inflated, passing the lifecycle owner, passing the view model, and then returning the binding.root. And then the lifecycle owner there is calling view data binding.set lifecycle owner. And the view lifecycle owner there is calling fragment.get lifecycle owner. So, and then later on in onActivity created, which is actually where you would make your calls to live data. So if you want to observe live data, this is actually where you would actually do it. So in my case, the view model, I'm referencing a variable called navigate to dashboard. And this is basically a variable that has been defined in the view model to say, hey, view model, the view model controls whether to tell the fragment whether to navigate to the dashboard or not. So the view model, like I said, is the management and the storage of the UI-related data. So it'll basically dictate when the view, its UI controller, needs to perform a certain action. In this case, navigating to the dashboard. So as you can see there, it'll basically call the find nav controller, and I will touch on navigation later on, but this is how you basically call it there. So it will use the login fragment directions and then action login fragment to dashboard fragment, which I'll explain later what this actually means. So this is where all your live data observation will go. So it's basically observing it. And then as you can see there, I'm saying if it, in this case, it is actually a Boolean. So if it's true, then navigate. If it's not, then it's not going to execute that function. And then there I'm just basically having a function called navigate to dashboard complete, which basically is to notify the view model that this action has been done. You can now basically set it to false. It's basically a personal preference. You can also implement it your own way. And as you can see there, I'm in on destroy. I'm then setting the binding to null to prevent any memory leaks. Okay, so login view model, and this is what it looks like. So it's got navigator dashboard. It's another mutable live data, which means the login view model is the only entity that's responsible for the mutation or the changing of the data associated with navigating to dashboard. And I've got navigator dashboard there, which is the one that the fragment will have access to. And then that's a live data, which the fragment can observe. Then I've got navigate to sign up. So all of these variables will basically tell the fragment that, hey, when they're true, I need you to navigate to the dashboard. Or when the variable is in a certain way, I need the UI controller to behave in a certain way. Okay. And then this is how it has. So this is the factory that I mentioned there. So the factory is what gets passed on with the view model provider. And this factory there will basically have constitute a utility class to provide a view model. So it's using viewmodel.factory, which is basically the interface responsible for instantiating the view model. So navigation, which is the fun part, so wiring all of it up. So this is how I implemented navigation. And first of all, what is it? It's also part of Android Jetpack. It is a collection of libraries, tooling, and guidance to simplify Android in-app navigation. And that's the whole point of it, to basically simplify. There's a whole lot of things that we've had to do as Android developers in order to be able to navigate around our app. The whole point of navigation, of this navigation component, is to make things easier for us. And so it constitutes one of three things. One of them is basically using a navigation graph to outline navigation information. And this is basically constituting of all possible paths that a user can take within your app. It also is an XML file. So you can, if you want, edit the XML file, or you can actually use the navigation editor within Android Studio in order for you to be able to update your navigation graph. I'll actually show you what it actually looks like. And then another part is then navigation constitutes of a nav host. And this nav host is basically an empty container that will display the navigation graph's destinations. So all the destinations defined in your navigation graph, the nav host is responsible for then displaying this information. And you can also use the default provider, the default nav host, which is nav host fragment, in order for your nav host. And then the third part is the nav controller, which is actually responsible for controlling and managing the in-app navigation. So it's responsible for swapping the destination. So your fragment A, fragment B, it's responsible for swapping the two and then displaying the relevant fragment that the user has selected to display. And then this is basically what the navigation graph looks like within Android Studio. So here you basically need to name your file within the navigation directory. So navigation there, and then I've called mine nav_graph. You can name yours whatever you want. And then there on the right hand side, you will see there graph. And then this is basically the graph. So it contains login fragment, dashboard fragment, sign up fragment, video list fragment, just basically all the fragments that I have. And you can, if you check on the plus there on the top there, you can basically add your own destinations. And this here is just a visualization of how all the fragments are tied together. So I have login fragment, which basically navigates to dashboard fragment, which can also navigate to video list fragment, which can also navigate to store fragment. So you can basically define all these parts within your navigation graph. And the nav controller will be responsible for navigating between these within these graphs. And then on your right hand side there, you basically have attributes that are defined. So at the top there is the name of the action. So when I go from video list fragment to video detail fragment, the action that's defined there, you can also rename it, but the default one will be the name of the fragment. So in this case, action_video list fragment to video detail fragment, and that's the name of the action. So basically, that's what you pass in when you're navigating. And then that's the ID there, the destination, where it's supposed to go. You can also define animations, so slide transitions and all of that you can actually incorporate in here. And then the XML version. So I've shown you what the editor looks like. This is what the XML version will look like. So this is one part of it. So in the nav graph with XML, this is one of them. So fragment, so going from the video list fragment to the video detail fragment, this is what it'll look like. The ID there, video list fragment, and then the name there. You can also pass a layout, which is optional. That'll just basically give you an overview within your editor, what it will actually look like. But the action there is the one that the controller will follow. So in this case, action video list fragment to video detail fragment is basically saying, I want to go from the video list to the video detail. It also can also go from the video list to the store fragment. You can define a whole bunch of actions, and your nav controller will follow whatever you define within this graph. So within main activity, I then need to define what is called a nav host. And so like I said, I have one single activity, and that single activity is the nav host. And so I'm using my main activity as the controller for navigation, which is actually the recommended way when you're using the single fragment approach. And basically, you'll see I've given it the default nav host fragment as the name. So that's what you need to pass in there. And then default nav host equals true. This basically means gives control of main activity to be able to intercept the back button actions. And another note is that the default nav host can only exist on one instance. You can only have one default nav host. You can't have more than one. And then there at the bottom there, you define the nav graph. So you can either put it in your XML, or you can define it within your main activity, or whatever class is acting as the UI, as the controller. You can define there the nav graph. And then there at the bottom there, the fragment tag usage. So this is one of the issues that I encountered during the hackathon. And it was the recommended way is to basically use the fragment container view instead of fragment. But currently there is a known issue with trying to use fragment container view and having navigation working. So this is basically just an override until that issue, this known issue which I've tagged there, is actually resolved. Okay, so nav host, so adding the bottom navigation. This is how I added the bottom navigation, basically using the material bottom navigation view, passing in the menu there. And then the bottom navigation menu, this is what it looks like. And this is how it maps to each and every screen. As you can see there, each and every ID, dashboard fragment, video list fragment, store fragment, each ID there should be the same name as what you have in your nav graph. That way, when you actually navigate between the fragments, the UI controller will actually be able to map it correctly to each and every fragment. It's smart that way. Okay, so the nav controller, this is how I've defined things. And I just have to speed through because I'm running out of time. The nav controller there, so I've defined it as the global variable there at the top there. And then I'm using the find nav controller, which is part of the activity. So find nav controller, and then that's the ID that you need to pass in of the particular nav controller that you've defined in my case, in a main activity, I've called it nav_host fragment. And then I've also given it what is called an app bar configuration. And what this actually does is that there are certain screens that the navigation will add a back arrow to, and basically assume that this particular screen is not the main screen. So what this does is it overrides it. And I'm basically telling the nav controller that no, login fragment, dashboard fragment, video list fragment, and store fragment are primary screens. There are no child screens, so I need you to treat them as that. Don't add the back arrow for this. These are actually main screens. And then there you set up action bar with nav controller, passing in the nav controller and the app bar configuration in order for you to be able to have this set up within your main activity. And then for the bottom navigation view, you also need to give it the nav controller so that the two can actually work together. So this is where you then pass in the nav controller as the argument there. So, and then on activity created, so going back to when I mentioned there, when I said I needed to pass in the navigation information. So this is where I'll now come back to this now. So you've got login fragment directions, Okay, so that's the action that is automatically generated for you. So when you add this fragment to your nav graph, this is actually generated for you. So login fragment directions is automatically generated, and then you then can get access to all the actions that you have defined in your nav graph. So in my case, I've got access to action login fragment to dashboard fragment. And now basically I'm then saying, hey, this find nav controller. So you're giving the allowing the fragment to find the nav controller and then calling the navigate option to then navigate to that particular stream. So this is how simple it is. This is how you can navigate from one screen to the next. No extra things that you have to try and do, managing the backstack and all of that. The navigation component actually takes care of this, which is why it is actually such a beautiful thing to use. And so you will basically have, in my case, this is my prototype where I could click on the login button. And when I click on it, I can then go to the next screen and so forth. And you can see there with my bottom navigation, everything is all tied together with the navigation components included. And this is the end of my presentation. And thank you. So for any resources, I would recommend developing apps in Kotlin, which is a free Udacity course, which actually is incorporating Android Jetpack. So if you want to actually get started with Jetpack and understanding it, this particular course is really good, and it's free on Udacity. Another resource is actually just visiting the developer.google.com/jetpack for any information about Jetpack. And then all those binding adapters that I gave there, that huge list, this is where I got them from, the Android X data binding adapters. And that's me.
Wow, wow, wow. Thank you a lot, Ahmed. That is a brilliant talk. Like, I've learned a lot, and I hope our viewers have learned a lot from you. Coming up with a production ready application in 3 days, that is quite a feat. And
Yeah.
I have one question, might be silly, but what out of the many Jetpack libraries, which one did you find was your best, one of your best to use?
I would say I would say the navigation one. Mainly because I mean it's always been a mission for people to be able to just have a bottom navigation and then just try and tie it all together, and move from one screen to the next. But just these simple things where you just make sure that your IDs match in two places, and then bam, and then set up your UI controller, your nav controller, and suddenly you now have this app that can just navigate from one screen to the next. That I found to actually be fun to use. Probably after that, I think it's the view model. Yeah.
Okay. We do have a few questions from our viewers. I'm just going to show them on the screen as a banner.
Sure.
Give me a second. All right. So Laurie Sheepers asks, referencing variables in XML was not nice back in 2017. Has data binding changed much?
I haven't actually seen any issues now using it, as long as you reference them correctly within that data object, and then when you then define them in your fragments. So just make sure that your binding actually is aware of those. So, for example, if you're passing in the view model, so if you define the view model in your XML, just make sure that in your fragment or in your activity that you have binding the view model and actually passing that in correctly, then I shouldn't see any issues. On my side, it's actually been working smoothly. As long as you connect the two properly, then it should be fine. I hope that
All
answers
right,
your question,
great.
Lauren.
Let me get cool. Let me get some more questions right here. Maya has a good one. Um, Maya asked, with larger projects, the data binding adapters can get out of hand. Do you have any tips? for wrangling with them, naming conventions or folder structures?
Um, yeah, so that can actually be a pain. What I've had to do, so even within those binding adapters, I guess you could create subdirectories. Again, it's a personal preference thing. On my side, because I haven't had to write a lot of them. So like maybe a mammoth list of binding adapters where it's now been forced to have to be in different directories. But what I've done is just to be able to organize them better. Maybe so if they relate to text, if they relate to so I basically have one of my apps which I'm busy with, which basically touches on I'm using different API sources, and these API sources I need to transform the data in a certain way. And so I basically, within the bindings directory, I then have subdirectories that name so the different API sources. So you could also take that approach, or maybe even the different types of binding adapters. If they tie into text binding adapters, so anything that relates to text, text manipulation, all the stuff, maybe have it in one directory, and so forth. So maybe that will make it easier. It's just suggestion. Yeah. Hope that helps, man.
All right, awesome. Other question, like, could you use a combination of activities and fragments in the navigation graph?
That is actually a good question. So if you're going to use it in the recommended way, you would only have one single activity, and that activity becomes your nav host. So you don't have to actually reference activities within the navigation graph. So the idea is to have only one activity as part of your architecture. So in my case, it's main activity, and that's it. I don't have any other activities that are part of my code. And then I have different fragments, and then these fragments are become then the destination. And even if you notice within the nav graph, when you're actually adding a new destination, the preference way is actually adding another fragment as the destination. I'm not sure whether if you are then going to be doing a multi-activity type architecture, whether it'll actually work well. It's worth exploring, but I definitely would not recommend it. I would recommend main activity, multiple fragments. Hope that helps.
Awesome. One more question, and on a lighter note, get it?
Yeah,
Did you win the
so
hackathon?
unfortunately not. I mean, we actually tried our huge best. We thought that this project was actually going to be a winner, but the competition was really, really stiff. So no, we didn't win. The good part is that the organizer of the project did end up taking it further to try and get sponsors and all of that. So it actually is a project that I think is going to take off. So hopefully with sponsorship, I feel like it will take off. But no, Sylvie, we didn't win. Yeah,
All right. Thank you very much, Ahmed. It's been a
thank
pleasure.
you.
It's been lovely listening to you. I hope everyone enjoyed listening to you. And we shall see you soon in another meetup.
Thank you.
All right.
Thanks, man. See
You're
you.